Jacinta has 12 cards she wants to trade. Jade has 18 cards. How many more cards does Jade have than Jacinta? First thing we want to do here is decide the model. So do we have a starting value that we're changing by increasing or decreasing it? No, that's not happening here. We have two separate things. We have what Jacinta has and we have what Jade has. So we know this is not an add to or take from. So are we putting together their two cards or are we comparing them? Well, by asking how many more cards does Jade have than Jacinta, we're really doing a comparison. So this is an example of a comparison problem. And so if we look at our models handout, we can see that for comparison problems, the correct setup equation should be the bigger value minus the smaller value equals the difference. So in this case, the two values I'm comparing are the number of cards Jacinta has with the number of cards that Jade has. And I actually do happen to know what both of those are. I know that Jacinta has 12 and Jade has 18. So between the two of those, the bigger one is the 18. So this is going to be the bigger one minus the smaller one would be Jacinta's 12 cards. And so what I don't know and what I'm trying to find is the difference, is how many more that Jade has than Jacinta. So this would be my setup equation here. And then how would I solve it? I would simply do 18 minus 12. So in this case, it is a subtraction equation, and I would also use subtraction to solve it. Then if you look at part B, it says how many cards do they have together? So now the two separate things that we have, I'm no longer comparing them, I'm actually putting them together. And so this means that this is a part-whole problem. And for those set of equations, it's always one part plus another part equals a whole. So of course, I know the two parts this time. I know both what Jacinta has and what Jade has. So this should be 12 plus 18 equals, and I'm trying to find the whole, what they have together. If you did 18 plus 12 equals question mark, that's also correct here. So either one would be fine. And so since I actually know what those two values are, this is a put together problem. So we knew from the start, pretty much it was a part whole. It was just a question of, were we missing an add-end? So did we know one of the parts in the whole and are trying to find the other part, or did we know the two parts and try to find the whole? Here, since we knew the two parts and are trying to find the whole, it's a put together. And how would you solve that? You would actually add. So it is an addition equation, and we would actually solve using addition. We'd add 12 and 18. Next, let's look at this one with Bree and Bo. So it says Bree's lunch total is $13. If she pays with a $20 bill, how much change will she receive? So we know that she needs to pay 13. She's paying with a $20 bill. So she has that 20. She's paying 13. We want to figure out her change. So do we have some starting value that we are changing somehow, that we're increasing or decreasing? Yes, we actually do here, right? So if we think of it as the second number they stated, the $20 is what she's starting with. That's what she has, right? And we are decreasing that, right? She is from that $20 paying for her lunch. So this would be an example of a takeaway or take from problem. So for our take from problems, the equation should be the starting value minus the amount of change equals the ending value. So here our starting value is the $20 she has. And then how much are we changing it by? We're changing it by however much her lunch costs, in this case 13. And then we want to find out how much she will end up with, right? So how much change she will get. So that would be our setup equation then to find the ending value, the change. And so how would I solve that? I would simply do 20 minus 13. So this is a subtraction equation, and I would use subtraction to solve it. Looking at part B on number 2, it says Bo's lunch total is $15. How much less did Bree spend? So now I'm talking about two different things. I'm talking about Bree's lunch and Bo's lunch. So am I putting them together to see like how much they spent all together, or am I comparing them to see like a difference? In this case, I'm comparing, I'm trying to find how much less did Bree spend. So this is a comparison problem. And again, our comparison that we did earlier is bigger minus smaller. So Bree's was 13, Bo's was 15. So I know what the two things are that I'm comparing. And so I would just do bigger minus smaller equals the difference. And that's what I'm trying to find, is how much less did Bree spend since she only spent 13. And so of course I would solve that by actually subtracting 15 minus 13. So eventually the equations and the way we solve it will not always match, but so far they are. So then let's look at number 3. Samuel has $22. He wants to buy a new bike helmet that costs $55. How much more does he need? So do we have a starting value that we are somehow changing, like we're trying to increase it or decrease it? We really don't. Like if he was already, like if he already had the money for the bike helmet, then that would be different. Then we would actually be spending the money. We'd actually be buying it, right? But here he needs that money. He's still trying to come up with that money, and he doesn't have that. So he has a part, he doesn't have the other part. And so this is really a part whole problem, because we have the part that he has and the part that he doesn't have in order to get this total, right? The total cost of the helmet, which is 55. So this is a part whole. And in terms of which one it is, so is this an unknown addend or is this a put together? It depends on if I know the whole or not. And so we're saying that the two parts would be the part of the money that he has and the part of the money he doesn't have. And then the whole would be the total cost of this bike helmet he wants to buy. Well, I actually do know that total cost. That's 55. So since I know the whole, I don't know one of the parts, right? I know the whole and I know the part he has. I don't know the other part. So this is a missing addend or unknown addend. So for unknown addend, just like put together, it's part plus part equals whole. So this is an addition setup. And so I would take the two parts, add them together to get the whole. So the part that he has, I know, is $22, plus the part that he doesn't have yet, which I don't know. I don't know how much money he still needs. But then I know that that should equal the whole cost of the bike helmet, which is 55. So this would be my setup equation. Now, how would I solve that setup equation? Actually, I would need to subtract 55 minus 22 to find that difference. So even though it's an addition setup, we would solve this one using subtraction. Then we have part B. It says Samuel's mother gave him another $20. How much money does he have now? So he started with the $22, right? And now his mother's giving him another 20. And we want to know, if it were asking how much more does he need, then we'd be back to unknown addend. But we want to know how much does he have now. So do we have like two parts and we're putting them together, or are we changing a starting value? In this case, since she's giving the money to him, that is getting added to what he has. So this is an add to problem. We are physically adding to the money he currently has. He has a starting value and we are changing that starting value. So for our add to problems, the equation is start value plus change equals end value. So in this case, he started with, now this is technically coming from part A, he started with the $22. And then do we know what we're changing that by? Yes, we do, because she gave him another 20. So that's how much we're changing it by. What we don't know is this new ending value, how much money he has now. So this would be our setup equation. And then the way we would solve that is we would add 22 and 20. So this is addition setup, and we would also use addition to solve it. For number 4, Matt threw the beanbag 3 meters farther than Tom. Tom's throw measured 9 meters. How far did Matt throw the beanbag? So are we talking about like adding to how far he threw it? So like if that were the case, we might be looking at like he threw it this far and then this much further, right? And then we want to know the total. So we might be adding to, if he threw it maybe more than once, we would be adding to it. If we were gonna talk about putting together how far they threw, and we want to know how far they threw in total, then that would be a put together. In this case, we just want to know how far Matt threw the beanbag, and we know he threw it 3 meters further than Tom. So it's not that he threw it 3 meters, it's that he threw it further than Tom, and we know how far Tom threw it. So this is actually a comparison problem. We are comparing how far Matt threw the beanbag with how far Tom threw it. So for comparison problems, again, just looking at my model sheet, it's bigger minus smaller equals difference. So the bigger and the smaller, those two things that I'm comparing, in this case, those two things would be how far did Matt throw it and how far did Tom throw it? Those would be the two things that I'm comparing, right? So that means it's either going to be Matt minus Tom or Tom minus Matt. It depends on which one's bigger. Now, this is hard because I don't know how far Matt threw it, right? I don't know that information. However, I do know that he threw it further than Tom, right? So that means that Matt's number is bigger than Tom's number, right? So that means Matt's is the bigger number. So even though I don't know what it is, Matt's number is the bigger number, right? So how far did Matt throw it? I don't know. But then I would subtract from that how far Tom threw it. Now his throw I do know was 9 meters. So I would do question mark minus 9, and then that should equal the difference. Well, what's the difference? Matt threw it further. How much further? It was 3 meters further. So the difference between their two throws is 3 meters. So this would be my setup equation. And so then how would I find actually how far Matt threw it? Well, if it's 3 meters further than Tom's and Tom was 9, I would actually add 9 and 3 in order to solve that. So even though it's a subtraction setup, I would use addition to solve that. Then we get to part B, and it says Anton's throw measured 11 meters. How much farther did he throw than Tom? So again, I know how far Tom threw, right? Now it's telling us how far Anton threw, and we actually know how far he threw it. We know it was 11 meters, not just 11 meters more, it was actually 11 meters. If this asked how far did they throw it together, that would be a put together, but it's asking how much further did he throw it than Tom. So this is another comparison problem. This time we're comparing Tom and Anton. And so I know that from part A, we know that Tom threw it 9 meters. From part B, we know Anton threw it 11 meters. So those are the two things I'm comparing. I would do bigger minus smaller. So this is going to be the bigger of those is 11 minus the smaller of those is 9. And I'm trying to find the difference. I'm trying to find how much further did he throw it than Tom. So this would be my setup. And then how would I solve it? I'd subtract 11 minus 9. So it's a subtraction setup, and I would use subtraction to solve it. All right, things are going to get a little trickier here on number 5. So this is not something that you would necessarily see very often. Typically, we would not give this challenging of a problem to students to decide on the model. Certainly, it's not that challenging to find the answer, but to decide on the model is a little bit tricky. So there's actually more than one possibility for the model on these problems, just depending on how you look at it and how you think about it. So if you look at part A, it says Monica's previous best race time was 61 seconds. She beat it by 2 seconds. What is her new personal best time? So I would kind of run through like I would normally do with my models. I would maybe just go one by one and kind of say, did they do this? Did they do this? So did we have a starting value that we increased? Did we have a starting value that we decreased? That would tell me if it's add to or take from. Do we have two separate things that we're talking about? And if we view them as separate, Are we putting them together so that it's a part whole? And maybe I know the whole, or maybe I know the parts. Or are the two separate things that we have, are they something we're comparing? Right? And so I think my initial thought on this was comparison, and I think that's one way to go. So I think that's probably where I would head with it. But I think you could also view this as her initial time, her initial race time. You could think of that as a starting value. She started with that time. And then what does it mean if she beats it by 2 seconds? Well, when we're talking about race times, the shorter it is, the better. So if we beat it by 2 seconds, that means we managed to decrease that time by 2 seconds. So you could think of that as she started with a value of 61 and then changed it by decreasing it by 2 seconds. So that would be a takeaway problem. So I think you could think of it either way. So let's talk about what that looks like. So, and I'm going to color code this so you can tell the difference in what I'm talking about. So let's talk about if we saw it as a takeaway problem. Then the way that we do a takeaway is we do the starting value minus the amount of change equals the ending value. So we would think of that 61 seconds as the starting value. And then I would subtract the amount of change, and it said that we changed it by 2 seconds, right? We're decreasing our time by 2 seconds. So we would subtract 2, and then we're trying to find what that new end time is, that new personal best time. So that's what the takeaway problem would look like. And then how would I solve that? I would do 61 minus 2. And so then that means I'd subtract to find my answer. All right, but then what if we viewed it as a comparison problem? So let's look at that possibility. So if we thought of this as a comparison problem, then that means we're comparing two things. What two things are we comparing? Well, we're comparing her previous race time with her new race time, right? That's the things we're comparing. And so we would do the setup equation would be bigger minus smaller equals difference. So which one is the bigger value, the previous best race time or the new one? Well, she beat it, so that means that it's now shorter, right? So that means the bigger number is the previous one. So it would be 61 minus, and then what's the new race time? That's what I don't know, right? I don't know what that new race time is. So I don't know that, but I do know that we beat it by 2 seconds. So I know the difference between the old race time and the new race time is 2 seconds. So that would be my setup. Now, I'm going to solve it the same way, right? Like the model is not going to affect at all whether you would add or subtract to find the answer, right? Either way I do this, I'm going to end up subtracting 61 minus 2, right? So this is going to be subtraction either way. But you can notice that that setup equation, it looks very different, right? It looks very different. So I would accept either of these answers. However, if you chose takeaway, then you need to have your setup equation be 61 minus 2 equals question mark. And if you chose comparison, then it needs to be 61 minus question mark equals 2. So yes, I would accept either there, just depending on how you viewed it. But you have to make sure that your setup equation goes with the model that you chose. So then let's look at part B, and I'm going to continue to color code so you can kind of see what the options are here. So this says the record time is 55 seconds. How much more time will she need to shave from her personal best to equal that record? So again, I feel like my inclination here was to say that this is comparison. That's just because we're comparing like these previous race times with new race times, right? So I think that's kind of where my mind goes. So you might explore that if that's what your intuition says, you might explore that and see if you can make it work. However, I think that again, we could look at this as are we taking away, right? So if we think of let's see, her record time is 55 seconds. how much more time will she need to shave from her personal best to equal that record, right? So she's trying to get to that 55 seconds, and we want to know how much she's going to need to shave off of that of that personal best time to get to that. I think this can be a little confusing because we're kind of combining these two parts. So when it says her personal best time, I don't think it's super clear here, and they should probably clarify that a little bit better, whether they're talking about the 61 seconds or if they're talking about, technically, if we had solved part A, 61 minus 2 would be 59 seconds. So I don't think that's super clear. So we could say, we'll go ahead and say it's 61 seconds, that's her previous best time, but I think if you used 59 there, it's open to interpretation here. They're not very clear on what the personal best is. So I'll just go ahead and I'll call it 61, but if you used 59, I'm okay with that. So if we think of it as we're starting with 61 seconds and we want to get it down to 55 seconds, if we think of that as a takeaway problem, then that means I would do my start value minus some change equals some ending value. So I'm going to take that start value of 61 and I'm going to subtract. I don't know how much I need to shave off of that. That's what I'm trying to find, is the amount of change. And then that would equal the record time. That's what we're trying to get to, is that record time of 55. So if you did a takeaway, that's the equation I would want to see. Or, like I said, it wasn't clear whether we were talking about the 61 seconds or if we were talking about the answer to part A. So if you did 59 minus question mark equals 55, that's just fine. So then how would you solve that? You would actually solve it by doing 61 minus 55. So you'd end up subtracting to find that answer. Okay, so how else could you look at it? What about maybe part whole? So that's another way that you could maybe view this one. I don't know that that's my favorite one, but I could maybe see it that way. This one is a little bit tougher than most of them. Most of them, they have a clear model. This one is a little iffy. So if I think of it as we have two separate things, right? Two separate things. I have this previous time and this new time, right? And so I'm thinking of it as, okay, I want to end up figuring out what I need to put together with this record time in order to get this my personal best, right? So if we think of it that way, if we think of it as a part whole problem, my parts, right, would be the part that I want to get to, the record time I want to get to, and whatever I need to shave off of that, right? And however many seconds it takes to get that to what my current record is. So I'm thinking of the 61 seconds as a whole, and then I'm thinking of the two parts of that whole being the record time I want to have and the time I need to shave off, right? So if you think of it that way, again, I don't know that it's my favorite, but I could see it, right? If you think of it that way, then my two parts are going to be, could say 55 is one part. What I need to shave off is the other part, and those two parts together, the record time plus the amount of seconds I need to shave off, would give me the 61 seconds I'm currently at. Or if you said equals 59 because of the answer to part A, that's fine. So if you view it as part whole, it would actually be that. And since I know the whole and one of the parts, that would actually be unknown yet. So I'm okay with either answer, but your equation has to match it. And you'd still subtract, right? I'm still doing 61 minus 55, no matter what model, no matter what equation. That's how I would solve it. So it's still subtraction to solve it. But then let's look at comparison. So, because I think that's kind of where I went initially is comparison. So let's see if we can make that work. So if we were viewing this as comparison, I'm comparing my current time with the record time, right? That's how I'm thinking of this, is comparing those two things. And so when we do comparison, it's bigger minus smaller equals difference. So between those two, 61 is the bigger one, 55 is the smaller one, and I'm trying to find the difference. I'm trying to find what I need to shave off, what that difference needs to be. And again, I would just subtract to find that answer, 61 minus 55. I think that one's the most straightforward in terms of like the equation and telling you what to do, whereas the other ones, you kind of have to figure out like, oh, how would I find that question mark? Oh, I'd do 61 minus 55. So this one's nice and straightforward. I think I prefer that, but it wouldn't be wrong to look at it the other ways.